Let's do it. Today we are going to talk about interfaces and polymorphism. Or at least one of the meanings of polymorphism. What is polymorphism?
Changing shape or form.
Yes. Poly is many, right? Morph or something like that is form. So many forms, right? One thing, one data type that can behave differently. One word that can have several meanings, right? We have seen ad hoc polymorphism, which is operator overloading, right? You can have a function or a method with the same name, and depending on the parameters, it can be a completely different function, right? Does that make sense? Now what we are going to see is parametric or type polymorphism. There is one other form of polymorphism, which I think was parametric polymorphism, which is generics or templates. Now, most people, when they talk about polymorphism, they mean this one that we are going to talk about. What we want to be able to do, we have a statically typed system, right? Statically typed language, Java. Everything has to have a type, right? So what we want is to define more expressive types. And so the main way to do it is to define what is called an interface that defines only behavior, describes only behavior, and then when you have your classes, so basically only methods, no data, when you have your classes, you say that you implement that interface. And then in your functions or collections or whatever, you can declare them to take the type of the interface, pass the classes, and they will call the right method. Does that idea make some sense? So what we are going to have is basically say an interface called shape, and we're going to have several different implementations, and depending on which one we have at runtime, the right gets called. So let's do an example. Imagine we are doing an elementary school geometry program, and we want to torture kids with formulas for areas and perimeters, right? So we could define a class rectangle. By now, you should be familiar with classes. So we would have, it's a rectangle, so we need to have the width and the height. We can have a constructor. And then we would have get area. That returns the area, and so it's width times height. And get perimeter returns the perimeter of a rectangle, and if you remember, it's 2 times width plus height. And if you don't remember, the formula is there. And then a toString method that would print, right? Something nice. Or maybe not so nice, but. Does that make sense? You can see how this could be used in a program that maybe uses random numbers to generate those things and then print them to the screen, right? In fact, assignment 9 is such a thing, I think. Your circle class could look like this, right? Class circle. It has a radius, constructor, and then the formulas for area and perimeter, and the toString, right? What is common among these two guys, rectangle and circle? get area, get perimeter, right, and toString, right? We have those exact same methods, right? Up to express that commonality, right? The way that we express it is with an interface. For now, we're going to assume that toString is magic. Later on in the lecture, we'll define why it's magic, but we'll explain why it's magic. But so we can create an interface and define the methods that it has. What's the name of that interface? iShape, right? And this is actually not very standard in Java. I think it's more from .NET and C# and those guys. To name your interfaces starting with an I. That kind of tells you that it's an interface.
It's a convention?
It's a convention, yes, it's just a convention. It's not a requirement, you can name them whatever. Normally you end up with interfaces and classes that have almost the same name, so you either name your interfaces I whatever, or you name your classes whatever impl or something like that. Many times. Does that idea make sense? So we could have a class called shape that would implement these things. I like this convention, or at least I liked it when I was writing these notes. It's one of those things, right? Good thing about conventions, there's so many of them. Good thing about standards, right? So we use the keyword interface instead of the keyword class. Other than that, it's almost like a class definition, except that we put semicolons at the end of our method declarations instead of braces and the actual implementation. Does that make sense? In this particular case, both of my methods return a double, and they take no parameters, but if they took parameters or whatever, you would pass those kinds of things, right? It's the exact same thing as a method or function declaration. Now, here comes cool magic. On my rectangle, I say implement iShape. Now I'm saying I'm implementing that interface. And the compiler will scream at me if I don't implement it. So let's create this one. I'm going to create a new package. In here, I'm Okara. At work, I'm Karamo, so that confuses me. They use different conventions. Now I can start creating classes in here. And again, I messed up my Eclipse, so I'm using IntelliJ. It's just a text editor. It's yet another IDE. So let's actually I'm gonna call it main, and I'm gonna what works better for you? Shall we make it all in one file, or shall we create the different files? Different files, just to make it more. I guess it works. I call it a class because it doesn't care. Interface. Ha! So I'm gonna cut and paste this thingy. Perfect. It can actually go compile and verify that it compiles, right? F is good, right? I haven't done anything useful, so now it's probably nicer if I create them as public. We couldn't do that in our normal thing because if you declare a class to be public, it has to live in a file of the same name. Unless it's inside another class. So. If I compile, build, make project, Apple F9. It compiles, right? Now what happens if I do this and don't implement the interface? This is a promise, right? And it's telling me you either declare it abstract or you implement that guy, right? If I run it, I'll get the same thing. If you were to run this in Gradle or something like that, you'll get something like this. It's telling me you promise that you implement that interface and you're breaking your promise. You don't have those methods. Does that idea make sense? There is one more thing if you want. You can use @override, which is an annotation. And that tells Java, make sure that this is actually a method from the interface or from somebody that I promised that I would implement. You don't have to, but it's kind of useful documentation. And if you do @override public void foo, and I promise that I'm overriding a method foo, and it's actually not overriding, I'll get a compiler error. So it's more documentation and slapping yourself in the hand, right? Usually for something this simple, it's not a big deal. For something where the types get complicated or something like that, or you have 5 different methods with the same name, then it may be mildly useful. In general, it's a good idea to let the compiler help you as much as you can. So I can do the same-ish here with my circle class, which I need to declare that I implement that guy. If I don't say that I implement it, I'm not implementing it, right? So what does this allow me to do? In here, I can have a shape rather than rectangle, s equals new rectangle. What's your problem? It's not an unnecessary semicolon. You think you're doing groovy. You're not. Oh. What did I mess up? This horrible thing. Yeah. Yeah. You know where you are. What are you complaining? Public class main. I'm not in a method. I'm an idiot. I didn't add my method name. Which is why this was so confused. And if I run this, I'm gonna get 12, right? When I called s.getArea, which code got executed? Rectangle.getArea, right? Now I can also do Does that make sense? What is this an illustration of? Polymorphism, right? When you see s.getArea, you don't know who is going to be executed. It depends on the actual kind of shape at runtime, right? Before we have seen everything is done at compile time. At compile time, you know exactly what's going to be executed. This way, you don't. It's magic and it's cool. I can actually do things like this. Maybe is an array of shapes, right? And so it can, I can use it, I can declare my variables of type shape, and then the right get area get code. Isn't this cool? It is cool. It is amazing, right? I mean, it is incredibly cool. And it's going to feel natural in only 3 weeks, because we're going to do 700 of this. Isn't that cool? Any questions about this?
What does circle look like again?
Like this.
Oh, yeah, well, that's more of it.
Sorry, couldn't resist.
Gee, thanks.
I have 2 kids, couldn't resist.
Can you go back?
Where?
Not too far.
So when you say S dot to string or I shape S, where are you getting S from? I don't understand.
This is the for loop that iterates through an array.
Right, I remember that.
So it's just the data type. This is the variable. And so basically, S is going to be iteratively all the elements in the array. So it goes the first element, and so S
So
becomes,
you're just telling me if that's where it's...
that's my name.
Okay.
And so inside the loop, when I say S, I mean the element. Depending on how you did the assignment, you either use this or use normal for loops. You can ask questions. You can ask them loud. No? Okay. Does this idea make sense? Cool. So that is the cool thing, right? I can also have things like this. I have a method or a function, right, that takes an I shape, and I'm going to return the shapes to string, area, perimeter, and I'm going to call everything, right? So I can make this nicer and call that guy. And I get it prettier down there.
Quick question. For where you have like I-shaped shapes and then like the array, if you took that I-shape out of there, what does it do again?
If I
'Cause
take
it doesn't know.
if I take this word out,
Well, I guess it wouldn't like.
I get a compiler error, right?
But I mean, like if you hadn't done the interface and you had the get.
If I do rectangle,
Oh, okay. So
it's gonna complain, right? Because
circle doesn't have.
circle is not a rectangle, right? A circle is not a rectangle, so I can't stick it there,
Okay.
right? And I couldn't also make it an array of circles because there are no circles. By defining my interface with all the methods that it has, and then the using that interface as the type, then I can have whatever inside. Right?
Now, can you use rectangle normally, even though it's...
I can use a rectangle normally, yes. I can do rectangle. So I can use the rectangle either way, right? As a normal class or as an interface. I could actually interface my class could interface a bunch of different things. And then I can use it as either one of those 17 things. Does that idea make sense? In fact, I can have another interface, let's call it I have area, because they could declare my rectangle to implement both of them, right? And that's perfectly okay. In here, I can do and hopefully it works. You can't do it the other way around, right? Because every rectangle is an I have area, it's also an I shape, but not vice versa, right?
Overload the return type?
You cannot overload on the return type because the compiler cannot know which one do you want. You could want to cast that return type or something like that. You have to overload on the parameters, on the arguments.
But you can overload this interface functions, right?
I can, yes. I could have
Double and int and all that stuff.
not like this, but I could. Right?
Okay,
You can't do this, right? This you cannot.
yeah.
Because the compiler would not have a way to distinguish which one you want. So you can overload based on the arguments. You actually could, instead of this, just do when an interface that it extends another interface, it gets all of these methods through inheritance. Does this idea make sense? Interfaces are incredibly cool, and we use them all the time, right? They make our types very, very, they allow us to express a bunch of really cool types. So they make our code nice. Make sure then, yeah, this is inheritance of interfaces, which would be, yeah, almost what I did, right? We could define an interface I-shape with area, an interface I-shape with perimeter, and then I-shape will just say extends I-shape with area and I-shape with perimeter. The pure interface is a very clean concept. We have, now Java, you can extend interfaces a little bit with some kind of default methods that start making stuff complicated. But isn't this cool? And now let me talk about something that we don't use much, but we sometimes use. This is actually equally cool as a concept, except that in real life it ends up being not that useful. You can define a class with fields and methods. In this case, I'm calling that class base person, and we'll see when we have inheritance, you have the dad class is called the base, and the children classes, right? So you have base and derived or something like that. So I define my class base person that has a field name, a field a field date of birth, right? And then I have a constructor, a method get name, a method get date of birth. And then I could have a class employee that extends this other class base person. Same that we use for interface inheritance, right? We use implements when a class implements an interface. We use extends when an interface inherits from another interface. Here we are, it's a class inheriting from another class, so we use extends. And now this employee class gets all the fields from base person. So this employee class has a name and a date of birth. Does that make sense? So we can probably go play with this. And I need to import local data. This will do it for me. If I ask it nicely, yes, it's telling me. That's option enter. Dates are a pain in the neck in general. They seem very easy, right? We use dates every day, right? Except that, no, it depends. It has changed throughout history how we counted days, and it actually changes throughout time and space, right? Different cultures choose dates, count days differently, and so dates are actually a horrible pain in the neck. And Java has 2 or 3 different versions of dates that are horrible to use. Local date is one that is almost usable. So I have my base person. Let me close all my things. I'm gonna have employee class. Then make these things public. This guy is public. Is this guy public? No. Just for fun. They don't really need to be, but. Let me copy this. I think if I just do this, it works. No. Oh. No. Oops. This guy. And we get the default toString, which is horrible. So we can actually have now what happens, right? That's the base person. Let's look at the code for employee. What does this mean? I inherit from base person, which means I get all the fields, right? Now, I'm going to get an extra field, which is an SSN. Now, in my constructor, I get a name, a date of birth, and an SSN. I call, and this is a special keyword, super. I call the constructor of my base class. I call my super class. And then I assign my SSN, right? What happens if I do employee e equals new employee of Michelle, local date of now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully it's nobody's SSN. When I call this, right, that automatically calls either toString, right? So which toString gets called? The one from base person, right? Because I haven't defined one in employee. Does this make sense? When you call a method on an instance of a class, it navigates the inheritance hierarchy. It's a chain, right? Every class in Java inherits from object with a capital O. That object class has a toString method that prints the horrible things, right? That object.toString prints, if I delete or if I comment this out, I get the object.toString, right? Which is this horrible thing. It is the full name of the class, so karam.people.employee, and a horrible number. That horrible number may or may not be a horrible hexadecimal number, which may or may not be the location in memory. It's just a horrible number, right? If I define one in base person, and that is the object.toString method. Every object will print that. If I define it on base person, when I call it here, even though it's an employee, right, it's not going to get the one from the object, it's going to get the one from base person, which is closer in the hierarchy, right? And then if I define one here, and I were to run this, I get the one for employee. Now what happens if I do this? Which toString method gets called? I actually make it clear. So is it going to print base person or employee? Raise your hand if you think it's going to be base person. Raise your hand if you're going to be employee. Yeah, okay. And everybody else, abstentionism always wins. It is going to be the employee, right? This is another example of polymorphism, right? At compile time, you don't know what's going to be called. It depends on the runtime value of that variable. Isn't this cool? This is actually incredibly, absolutely cool. Except that sometimes can make your code complicated and hard to understand. It is still incredibly cool. I tend to not use it that much because it can make your code hard to understand, and I like to make my code simple enough that even I can understand it. That's the point. One super important thing. Make sure that you understand polymorphism and that you remember the weird word. Because I can bet you that in 80% of your work interviews, they're going to ask you what is polymorphism. So remember that this is polymorphism, right? If you want to be fancy, you can mention generics and overloading as other examples of polymorphism. But for the most part, when people talk about polymorphism, this is what they mean. Because the object-oriented people popularized the term. And with this, we have covered most of the object-oriented stuff, right? You have encapsulation, your methods and your methods and your data are together, and you can also do private stuff. You have inheritance and you have polymorphism. With this, you can pass job interviews now. You can pass the first layer of a job interview question, right? So it is important that you memorize the terms because it's going to be there every job interview. Now, let's talk about useful stuff. Yeah. Just be careful with class inheritance. If you can, actually do some cool stuff with class inheritance to get it out of your system, and then be careful with class inheritance. It's very easy to get convoluted stuff where you forget what the heck is going on. One important limitation of inheritance in Java, of class inheritance, you can only inherit from one class. Multiple inheritance can lead to even bigger messes. And so in Java, they decided to not allow for multiple inheritance of classes. You can implement however many interfaces you want, but not classes. Okay. One slightly horrible thing. In Java, we have primitives like int and double and those guys. Then we have objects like base person and employee, right? And they are different. One's are passed by reference, the others are passed by value, right? We're going to see next class or next week collections and how they allow you to, they are like super nice arrays, or better than arrays. But they cannot contain primitives. They only deal with objects. And if you want polymorphism and those kinds of things, right, or inheritance and things like that, you need objects. So in Java, what they did is created classes that correspond to the primitives. And they are kind of the same name with a capital letter, because classes start with capital letters. Except that that would have been actually useful and consistent, right? And the intern with ADD that they hired to do this couldn't do that, right? So some of them are the type, and some of them complete the word, right? So instead of you have your primitive is int, it would be obvious that your class would be called capital I int. It's called capital I integer, because it wouldn't be confusing enough otherwise. So double is double, float is float, char becomes character. Do we need a special one for string? No. What is a string? It's an object, right? So I can do something like this. Integer I equals new integer of 3. And then I can get int j equals I dot int value. And that will get me the int rather than the integer. Does that idea make sense? Actually, they are slightly nicer. You can convert from int to float and things like that through these classes. But basically, they are just a box that contain a primitive. They are immutable, so you cannot set the value. They are just, you can only get it. You can only set it when you build the instance, and then that's it. Now, after Microsoft hired a bunch of smart people, and they implemented this on C#. Some decided that they couldn't suck so much, so they implemented the same thing in Java. This is called auto-boxing and auto-unboxing. The compiler should be able to figure out when you mean an int and when you mean an integer. And so, in most places, you can use them interchangeable. Basically, you can declare this, right? And then do this. Int j equals I. And the Java compiler will get, oh, what you mean is not I, but I.int value. And insert the .int value for you. Does that idea make sense? And they'll do it the other way. It is important for you to know that this is actually happening because it only works 80% of the time. So the other 20 you need to be explicit. Does that make sense? So you just need to be careful. Isn't this cool? Mildly cool. Could be cooler. It's going to be winter soon. Any questions on box values and auto-boxing and unboxing, or inheritance, or interfaces? No? It's all cool. Your assignment 9 does similar stuff. Where am I? In assignment 9, I'm asking you to basically implement a bunch of other things. I give you rectangle and circle. I require you to implement square. And for square, I give you half this stuff. I ask you to also implement regular polygon. Then we have a factory class. One of the things that we use is a random number generator, randomish number generator. Basically, once you create your random thing, you can ask it for next int, and it gives you an int. And you give it the maximum. This factory has a getShape instance method where you do basically a switch or an if and create the right thing, so that we have a way of doing that. And then ask you to implement a couple of things by using an array of high shapes, and then by doing this other stuff, this main become prettier. One thing that slightly sucks about this assignment is that I'm asking you to create a class, regular polygon, and I'm not giving you the class, which means that Gradle W grade, oops, doesn't even compile because that class doesn't exist. Hopefully. I'm not lying to you. Yeah. So the first thing that you need to do is create that class, even if it doesn't do anything useful, so that you can get compilation. Does that make sense? Most of the other assignments, I give you code that compiles and is wrong. This one, I want you to create a class from scratch, so I cannot give you code that compiles. Does that make sense? Cool. Any other questions about assignment 9, assignment 8, the meaning of life? Yes?
You could boil interfaces down to sound like what would you say?
Define the methods of a type.
So we're just going to be, when we use interfaces, we're just passing values through, right? Because there's no data.
There is data, right? It's just when you define the interface, you're doing only the method, right? When you actually instantiate and use an instance of that interface, that is actually an instance of a class that has data and stuff.
So just because the data is defined before you create the interface, there's no data.
Exactly. It's just that it's kind of one more level on abstraction. Right? So that's, yes, this class will hopefully get you to think way more abstractly than before. Wait for 2 more levels and it becomes philosophy. When you start doing, when you start doing it in real life, it becomes philosophy. What's the right name for this class? What's the essence of this class? It's philosophy. Which is actually really cool. It's kind of applied philosophy. If there are no more questions, I will see you guys on Wednesday.